at parabolas. We saw from Khan Academy, looking at the introduction to conics, that if you have that double napped cone and a plane that intersects the cone, you could get a circle, you could get an ellipse, you could get a parabola, or you could get a hyperbola. And actually, if you cut that, if you cut the plane in the, well, here's your, if your cone was like this, and your plane cut through here, you'd get a point. If your plane went through here, you'd get a line. And if your plane went through, I think there's another way your plane can go through and get two lines. Those are called degenerate conics. Yes?
With the cone, why do they do like two? Like, can't you just have like one cone?
Well, you could, but it wouldn't be the conic section because you wouldn't get the upper half like the hyperbola.
Right.
It's a double napped cone. They call that a double napped cone.
But you can get like everything else with just one.
Yes, I think you could. Okay, so a point or a line or two line are called degenerate conics. And I'm not sure why they do that, but it's called a degenerate conics. You would think those are the kinds we would want to stay away from, but
So they're the type that
you would, if you went through where the cones meet, the plane went right through it, you'd get a point. If it went this way, you'd get a line, and I think you could get two lines if the cone, if it went straight down through the center. The plane went straight down through the center, you'd get two lines. All right, we are two intersecting lines. What we're going to look at today, though, is the parabola. There's different ways that we can talk about conic sections. We can talk about them in relationship geometrically to the double napped cone. We can talk about them algebraically, and they are second degree equations in x and y. We've done second degree equations in x before, but we've not done second degree equations in y before. I don't think you all got to conics last year at all, did you? Okay, so we'll be seeing some equations that have y squared with x linear. We'll be seeing some equations that are x squared and y squared. Yes, sir?
What happens, like, if you have conics, but, like, it's to the third power?
I don't think it would be conics. Because we're getting these particular figures out of conics. So I don't think you would get any with the third power. Okay, and finally we can describe them as a collection of points or a locus of points. You might see that word, a collection or locus of points. So today we're going to be looking at a definition that includes the collection of points or the location of the points, and we'll also be looking at it algebraically. Now, Mr. Kahn showed you a circle. If the plane cuts through the cone perpendicular to the axis of the cone, you get a circle. And hopefully you remember from a circle is a collection of points. And he may have mentioned this. A circle is a collection of points equidistant from a fixed point called a center. Equidistant from a fixed point. And we'll just let HK represent that fixed point, which is the center of the circle. I think we talked about this the other day after our SAT prep, but the standard form for a circle algebraically is x minus h squared plus y minus k squared equals r squared. So we have seen x squared and y squared in the same equation before, but it was a circle. So that is your standard form for the equation of a circle. I think you had maybe one or two questions on that practice SAT question about a circle. You've probably seen it. I don't know if there would have been any on the Iowa test or not, but it's possible because that's an Algebra 2 concept. I don't think we looked at circles in geometry. I don't think we talked about equations of circles in geometry. Now, we learned when we looked at a parabola before that it was we called it a quadratic equation. What we have seen before is in the form f of x equals ax squared plus bx plus c. This is a parabola that's either going to open up or down, but you could have a parabola that opens sideways. This parabola is a function. You have a parabola that opens sideways, it's not going to be a function because it won't pass the vertical line test. So we're going to look at a definition that allows us to have a sideways parabola. And it's based on the location of points. Okay, a parabola is a set of all points. The set of all points x, y in a plane that are equidistant from a fixed point called a focus and a fixed line called the directrix. Now the focus cannot be on the directrix. Focus is going to be kind of inside the parabola and the directrix is going to be outside the parabola. In fact, if we look at, this is our x and y axis, and here's your parabola, not very even. Your focus is inside, and your directrix is the same distance from the vertex that the focus is, and it is in this case, a horizontal line. This would be your directrix.
So the focus is the focus in like the direct middle?
The focus, we call this, we're going to see in a minute, we call this distance from the vertex to the focus P. And the distance between the vertex and the directrix is also P. The vertex is halfway between the focus and the directrix.
Oh, okay.
Okay, Aiden?
So like, every line, every point has the same distance from.
So I didn't draw this correctly, but
from,
yes.
like,
So you.
from to the focus to the directrix.
Yes, if I had drawn it accurately, this distance to the directrix from the point would be the same as the distance from here. All right, so let's see the standard form. Any other questions before we look at the form of the equation algebraically? This was our definition regarding the location of the points, or the collection of points, or location of the points. But when we look at the algebraic equation, and you saw one like this because we talked about one that was similar to this when we were going over your SAT questions. Let's say we have a parabola with the vertex HK. Usually we'll use H and K for center or vertices, but HK for a vertical axis. It opens up or down. Vertical axis. The form that the standard form is x minus h squared equals 4p times y minus k. If it's a vertical axis, y is linear, and then this p cannot be equal to 0. All right? P is the distance between the vertex and the focus. It's also the distance between the vertex and the directrix. Now, there's some formulas to get you there, but I think it's usually easier than trying to memorize a formula. It's easier to draw your information to determine what the focus is and what the directrix is, rather than me telling you the equation for the line for the directrix, how to find it. We'll do a few and then we can talk about the equation. If P is greater than 0, it opens up. If P is less than 0, it opens down. And I am going to have mercy on you when you take a test over this. I will give you a formula sheet.
Thank
Oh,
you.
then what's the
Thank you.
point of math?
You don't have
Go
to have
back
a,
to
I
your
can, you don't have to have a formula sheet.
Yeah,
I'll take the challenge.
Without one?
but that's only him.
That's only him.
Well, it depends on how many more formulas there are.
Well, we've got parabolas, we have ellipses, and we have hyperbolas.
Do they all just have one formula? Never mind, I know which.
Dude, you're diving into something that you don't even know what it is yet.
No, you're able to memorize it. Why would you not use your
Is there any manufacturer of mines for challenging?
Satisfaction. The thing is, I want you to be familiar with what these are, what they look like. You see them again. I don't want you to all of a sudden get to college and see these and have never seen them before. Right. I have not always in the past had time to get to the conics section. So I want you to be familiar with them so you won't say, I never saw anything like this in high school. Because now you have seen something like this in high school. All right, if we have a horizontal axis, then our equation is in the form y minus k squared equals 4p. Notice the 4p stays the same, times x minus h. Again, p cannot be 0. If p is greater than 0, it opens to the right. If p is less than 0, it opens to the left. All right, so let's just look at a couple of example problems, and I think you'll see why it's easier to sort of sketch the graph to figure out, okay, is this going to be an x squared or is it going to be a y squared? What's the equation for the, or what's the point that we're looking for the focus, and what's the equation for the directrix? Remembering that P is the distance between the vertex and the focus, and it's the distance between the vertex and the directrix. They're on opposite sides of the vertex. Okay, so 2p would be the distance between the directrix and the focus. Right? Paige.
So, is it both of them like added together? Like,
P is the distance between the vertex and the focus.
you'll
Okay, so let's do a problem. I think it'll help if you see us working one.
Directrix to focus, going all the way through the vertex, like the whole thing.
The whole thing, the distance between okay, let me just draw a real quick one.
There's like two P's, but it's all the same.
Okay, let's say that this is my parabola, and here's my focus. Let's say that the focus is the point 0, 0.02. Okay, between the vertex and the focus, I have a distance of 2. So my directrix is going to be y equals negative 2.
okay, so it tells you.
It tells you how far apart they are. How far apart the focus is from the vertex, and then it's the same distance from the vertex to the directrix.
So they're the
P
same.
is 2 or 4?
Yes. P is, in this case, P is 2. Our equation for this parabola would be x minus 0 squared, which of course you don't have to put minus 0, but that's the vertex is at 0, 0, equals 4 times P times y minus 0, or x squared equals 8y. Aiden?
How do you find out what the focus and directrix are?
Okay, sometimes they'll tell you, or they'll give you enough information that you can find it. Okay, so let's look at, and when we're just given a little bit of information. I want to find the standard form of the equation of the parabola with vertex 3, 2, and focus is 1, 2. So the first thing I've got to do is figure out, is this a vertical axis or is it a horizontal axis? The easiest way is sketch your points. Okay, so if the vertex is 3, 2, and the focus is 1, 2, then we have a horizontal axis. So what is P? What's the distance between these 2 points? 2.
So P is 1.
P is 2.
Oh, wait, no, never mind. Sorry.
P is 2. All right. Y is squared in this one. Well, actually, P is P2, or which direction are we going for the focus?
Right?
We're going,
Wait,
this
yeah.
is my vertex,
Is less. Oh, vertex.
so P has to be negative 2. P is
Oh, the
negative
view is the
2, but the
vertex.
absolute value of P is your distance. Okay, the absolute value of P actually is your distance, because it's opening this way.
Yeah.
So P has to be negative 2. But the distance between the 2 points is 2. You don't have negative distance. Okay, so we're going to have y minus 2 squared equals 4 times negative 2 times x minus 3, or y minus 2 squared equals negative 8 times x minus 3.
What are we trying to find the directrix?
Okay, we wanted to find the equation, the standard form of the equation of that parabola. But let's find the directrix.
Wait, which two did you, so whenever you plug it in, you use the
X
vertex?
equals 5.
Just in the, like, y minus 2?
Yes, this is your HK.
But like,
Okay.
Your vertex is your HK.
Oh.
Now, on my directrix, is it going to be an x equal or a y equal?
X equal.
X equal. Now, it's got to back up. If there's a distance of 2 here, I have to have a distance of 2 here. So x equals 5 would be your directrix. Yes, sir.
When you're finding the equation, is that how far, do you have to go farther than that?
If it asks you for the standard form of the equation, that's the standard form of the equation.
What's the directrix?
Yeah, the directrix is x equals 5. If we were going to graph it, that would be your directrix.
What is this used for?
Used for? Architecture uses a lot of the conic sections. You see a lot of arches. So they somehow can use those equations to find what they need to make the arch support everything that it's needed. Ellipses, a lot of your space applications would use ellipses and hyperbolas. Satellites. Yes.
In the one we did before, where that we got extra.
We want to find the standard form of the parabola with the vertex 2, 1 and the focus 2, 4. Okay, so that means this is H and this is K in my equation. I'm going to sketch just to make sure I understand which way it's going. So here's 2, 1, that's the vertex, and here's the focus. So the parabola is going to open up. In this case, what is P?
3.
P is 3. Okay, so if my vertex is here at 2, 1, I've got to go down 3 to get my directrix. So 1 minus 3 is,
-2.
so is it going to be x equal or y equal? Y equals -2. All right, so here's my directrix, but I want the equation. I just graphed it just so we could see what it looks like. Okay, is P positive or negative? Positive, it opens up. So we're going to have x minus 2 squared equals 4 times P times y minus 1. So that would be the equation of the line. Now, if you were asked to put this in quadratic form, this is standard form. Quadratic form, we just multiply out and combine like terms. In other words, solve it for y. Quadratic form, solve for y or x. Whichever term's linear. So we'd have x squared minus 4x plus 4 equals 12y minus 12. Add 12 to both sides. And for quadratic form, I would probably just multiply the whole thing by 1/12. And that's in quadratic form. Aiden.
Is there anything on your calculator that you can like do x equals instead of y equals when you're graphing?
The only way you could do that is with parametric equations where you'd have to have 3 equations. You'd have to have a third equation in terms of that relate x and y. So function-wise, no.
Miss Coco?
Okay, we have this equation.
Is that y equals?
Mm-hmm. And I want to find the focus. Okay, so this equation is in quadratic form. I want to find the focus. And the first thing that we need to do in order to find the focus so that we can get it in standard form so we can tell what the vertex is and we can tell what P is, we're going to have to complete the square. Yay.
Oh wait, I remember that vaguely.
Like the square thing, like you end of.
Like
Okay.
you bring it down and then
So,
it times
in
something.
order to complete the squared term needs to have a coefficient of 1. So I'm going to multiply everything by -2. So I have -2y equals x squared plus 2x minus 1. All right, I can't factor that. So to complete the square, I'm going to keep these two terms on one side and add one to the other. Now, in order to complete the square, we take half of this term and square it. So half of 2 is 1, and we're going to square that, and we add that to both sides. So I've got to add a 1 here. I didn't leave myself enough space. So now we have negative 2y plus 2, and this becomes x plus 1 squared.
What did you do?
Oh,
Remember, the reason we complete the square is so that we can factor it so it'll look like this. We take half the middle term and we square it and we add it to both sides. So I added the 1, and now I factored it.
Why is there not square on the other side? Like,
Because we didn't square this side. It didn't have a square with it. So if I factor out a negative 2, we have y minus 1 equals x plus 1 squared. So what is my vertex here?
How do you do that?
Negative 1. Negative 1, 1. H. K.
That's not fair.
Why not? Okay, so 4p equals negative 2, because this is 4p. So what is p? Negative 1/2. So we're asked to find the focus. Now, this is a parabola that opens up or down, left or right?
Down.
It opens down. So if my vertex is negative 1, 1, and it opens down, how'd you know it opens down? Because p is negative. All right.
How did you get 4p equals negative 2?
Because the formula says that the... Okay, so we want to find the focus. Y equals negative 1/6 times x squared plus 4x minus 2. First thing we have to do, I want to find the focus. So to get the focus, I need the vertex. Then we could even graph it if we wanted to. So I've got to get this term on the right so that that squared has a 1. So I'm going to multiply both sides by negative 6. Negative 6y equals x squared plus 4x. Now I have to add 2 to the other side. Now, what's half the middle term? So we're going to add 2 and we're going to square it. So really what I'm doing is adding 4. So I have to add it to the right side, the left side as well. So we have negative 6y plus 6 equals x plus 2 squared. These signs will always be the same. And the reason I put 2 squared instead of 4, so you can easily see what goes right there in your binomial. And I know you did this a little bit last year because I happened to sit in on one of the classes that Miss McKinley did. She was teaching the square, how to complete the square. Yes, ma'am.
Okay, so you know how you have negative 6y plus 6 on that side?
Uh-huh.
If you do the square, will it always work out that way? Or is there going to be a time where it's like negative 6 plus, I don't know, like 4 or something?
Could be. Then you would just you'd have to just reduce that fraction. Just divide 4 by negative 6. Okay, I'm going to factor out the negative 6. And so we would have y minus 1 equals x plus 2 squared. Now, if it makes you feel better, you can rewrite it. This is the way we actually saw our formula. So what is the vertex? Negative 2, 1. What is 4p?
Negative 6.
negative 6. So P equals
Negative 3/2.
-3/2. Okay, is this parabola up, down, right, or left?
Down.
It opens down because it is x is squared, so it's a vertical axis. So let's just kind of sketch it so we can see what's going on. So our -2, 1 is our vertex. It opens down, so we know that the focus has to be inside the parabola. So for the focus, what part of that point's not changing, the x or the y? The x stays the same. So we're going to have 1 minus 3/2, which is -1/2. So our focus would be right here. If I wanted the directrix, what would the directrix be? 5/2. It would be 1 plus 3/2. The directrix would be right here. Good. Okay, we'll do one with y squared. Y squared minus 4y minus 4x equals 0. Okay, I'm going to square in y this time. So we'll have to isolate the terms with y. So this is going to be 4x. Half the middle term is 2, so we square that and add it to both sides. So we'd have y minus 2 squared equals 4 times x plus 1. Okay, so again, I want to find the focus, and we'll find the directrix. What is my vertex?
-1, 2.
-1, 2. Up, down, left, right. Which, right? Okay. Okay, so 4p equals
Would it be 4?
4, so p equals 1. All right, so my vertex is -1, 2. And you told me it opens right. So what part of the focus this time won't change? The y is going to stay the same. What will be the x value? 0. So the focus is right here. And the directrix?
3. -3.
-2.
X equals -2. There's your directrix. So it's really, rather than trying to remember the formula for the directrix and the formula for the focus, if you will sketch the graph and find where your vertex is, which way does this open up? I think it's much easier to find the focus and the directrix rather than trying to memorize a formula for that. Team Guy?
What is the purpose to find the directrix?
It is part of that definition of a parabola, that all the points on the parabola are a fixed distance from the focus and the directrix. Those distances are the same. And there might be engineering applications where you needed to know those distances to keep them the same so that you would have structural soundness on something. Is on page 738. Makes it feel like we've gotten real far in the book, doesn't it?
Yeah.
Because we did skip a lot. 13 through 18. 20 to 60 every fourth. And then I want you to graph, and I'll get some graph paper out and put it on the back if you want to use it. 39, 42, and 45. Some of the others may ask you to graph it as well, so do that, but add these as far as graphing them to get some practice with graphing, and then you will have a quiz over 10.1 on Monday.